So in part 1, we talked about the Pythagorean theorem and saw how it's used to find any of the sides of a right triangle. The examples we solved were pretty straightforward, and what's cool about straightforward formulas is that you can combine them with other formulas and theorems and end up with problems that are a bit more fun and challenging. So let's see what we have today. Here's a right triangle, and we're given the length of B only. Find A and C given the perimeter. Since this is a right triangle, we can use the Pythagorean theorem. C squared equals A squared plus B squared. We only have B, so 8. 8 squared is 64. We can't do anything else, so let's frame it for now, and we'll get back to it later. What we did is we found an equation that shows us the relationship between the variables, but we still don't know the exact value of either one of them. The thing is, you won't find the value of either with only one equation. The number of variables you have determines the number of equations you need in order to find their values. So we have two values, A and C, and we already used the Pythagorean theorem to find one equation. We still need another one. So let's go back to the problem to see what else we're given. We have the perimeter. The perimeter is the sum of sides. So P equals A plus B plus C. P is 24, B is 8. Subtract 8 from both sides of the equation. 8 minus 8 is 0. 24 minus 8 is 16. The goal of finding these two equations is to combine them to end up with one equation with one variable to solve for. We're basically solving a system of equations by substitution. We have C and A in both equations, so that means we can rearrange one of them such that we can substitute it into the other. We want to rearrange it to get variable equals expression. Okay, so let's work on the second equation. Subtract C from both sides and it becomes A equals 16 minus C. A variable 16 minus C expression. And let's plug that expression into the first equation. Notice that the equation has A squared, so we'll have to open parentheses and plug what we have between them. So C squared equals A squared becomes 16 minus C quantity squared plus 64. We'll keep this equation on its side, but we'll need it later on to calculate A once we get the value of C. And here's our one equation with one variable. Now it's just a matter of rearranging the equation and solving for C. We can expand 16 minus C squared. We know that x plus y quantity squared is x squared plus 2 times x times y plus y squared. Let's apply that here. 16 squared plus 2 times 16 times negative c plus negative c squared. 16 squared is 256. 2 times 16 times negative c is negative 32c. And negative c squared is positive c squared. Let's put all the variables on one side. So add 32c minus c squared to both sides of the equation. C squared minus c squared is 0. 256 plus 64 is 320. Divide both sides by 32, so C equals 10. Okay, now that we have C, we can go back to this. A equals 16 minus C becomes 16 minus 10, and so A is 6. So now we have all three sides of the triangle. To make sure that we got the correct values, we can go to what we were given. The perimeter is 24, so we'll ask, will we get 24 when we add up the sides of this triangle? 10 plus 8 plus 6 is equal to 24, so check. Another way is to use the Pythagorean theorem since this is a right triangle. Is C squared equal to A squared plus B squared? 10 squared is 100. 6 squared plus 8 squared, 36 plus 64 is 100 as well, so check. And that's it. As an exercise, try solving the same problem by rearranging the equations differently and solve that by substitution, like this or like this. If you missed part 1, it's linked in the description. I'll see you again soon.